Welcome all. Today's guest is Ines Hartwig of Tomra Mining. Thank you, Ines, for staying late. It's 10 o'clock in the evening in Germany. Ines is Hamburg-based. Ines is a global mining product manager for Tomra Sorting. She has extensive knowledge of sensor-based sorting, having over 25 years of experience at Tomra while working in the recycling and mining industries. Ines has held numerous positions throughout her time at Tomra, including development engineer, test facility manager, recycling product manager. She received her engineering degree from Hamburg University of Applied Sciences. So welcome, Ines. Gonna hand it over to you now.
Thank you, Namina, and welcome everybody from wherever you are. So good morning, good afternoon, or good evening, like in my side. And thanks for having the chance to talk about some AI feature which we launched this year. Just as Namina mentioned already, so who am I? I work for Tomra since more than 25 years, live here in Germany, close to Hamburg. Really exciting city, so if you haven't been here, it's nice to visit. My background is actually electrical engineering with focus on automation. So I'm not a mining engineer, I'm not a geologist. So if there are questions related to that topics, please bear with me if I not be able to answer. But I will take everything with me, and we have good people in our team who could then maybe answer that at a later stage. And yeah, my current position is Director of Product Management for Mining. As Namina already mentioned, a long time with the company, so a lot of experience with sensor-based sorting. That's what we do here in Tomra Sorting. And that's, I think, we will talk today about. As mentioned, I work for Tomra. Who is Tomra? Tomra is actually a Norwegian company, stock listed in Oslo, founded in 1972 with some two men who developed and designed and manufactured and sold reverse vending machines for automated collection of used beverage containers. And that's still a big part of Tomra, so the collection part. And then within the 2000 and up to now, Tomra acquired a lot of companies doing sorting, sensor-based sorting, for different applications, for recycling, for instance, waste and metal recycling, for mining, like we, and for food. We have more than 5,000 employees globally, are busy with over 100 countries in all these businesses, and can say that innovation is one of our values. So we are a technology leader, and that's also how we develop certain features, applications, new machines internally, and that's what makes us successful. Just as I don't know who is really joining today, and to make give us a basis what is sensor-based sorting. In general, we can sort material which is liberated. So if particles are liberated and you have a good liberation between 2 to 250 millimeters, then there is a chance to use sensor-based sorting to separate the valuable from the non-valuable material. And here you see an easy principle. So it's a XRT sorter, so we use X-ray transmission here. It's a belt-based sorter, so material is fed via a conveyor belt. And the material comes from run of mine, which is typically crushed and screened. and then it ends up in a vibration feeder or a screen feeder, depending on the application. And the material is spread over a conveyor with, and then fed and analyzed by sensors. In this case, you see on top an X-ray source. The material is penetrated by X-rays. So we get, like on a doctor, you get an X-ray image from the moving rocks. So particles are scanned and the sensors integrated in the conveyor belt. And after analyzing and making a decision, evaluation of every single part, we have at the end of the belt a row of pneumatic valves. So we separate the two fractions with compressed air, and finally we end up with a waste fraction and an ore fraction, or with high grade and low grade material. Typically, this equipment is located before the milling. So either on the after the primary, secondary, or tertiary crushing stage, we integrate these sorters to remove the waste earlier before you put a lot of money into that and have the final processing step like flotation and others in that. So before you mill everything down to very fine particles, you can remove the waste, and in some cases it's 30 to 50% or even more. So it's a lot of material which can be, in some cases, even sold and used for aggregates, so building roads or other stuff, and does not end up in any tailing facilities. So that's what this typically looks like. Just if you haven't seen a sorter in action, here's a short video just to show the principle. This is an XRT sorter, so X-ray transmission. So that's why everything is covered to make it radiation protected. Material is fed from run of mine as crushed and screened into a pen feeder in this case. And then it's sliding down a chute onto a conveyor belt, and you see nicely spread it on the belt. Then it is scanned and passing the sensing, the detection area. Here with XRT, in slow motion, every single rock is really scanned, analyzed, evaluated, and then afterwards we make a decision if we want to eject it. Here you see the high dense particle and the low dense particle. In this case, we eject the low dense particles with compressed air. You see here nicely the row of the nozzles where the air jets gets out, and then it's separated into two fractions. The drop fraction is just falling down, and the reject fraction we actually eject with the air pressure. That's how a sorting machine works. There is belt-based sorters and chute-based sorters, but today we focus on X-ray transmission, so we focus on our belt sorter. And yeah, let's then jump into the real topic. So was asked to talk about artificial intelligence within our business. So I will give you some definitions about the wordings, because there's a lot of different names in the market: artificial intelligence, machine learning, deep learning, and so on. So just that we are talking about the same thing. Then I give you the motivation. So what was the driver for us to look into this field? Then the principle of Obtain, that's how we call the feature. And then the relevance for sorting, and also for sorting statistics, because data gets more and more relevant and important also for the mining industry. Then the benefits, and then we have a customer field evaluation to just show that this feature is really making a difference for our customers and clients. And that's what we talk about. And we are currently really live in very exciting times, because the development of electronics and computer power is steadily developing and makes us or gives us the opportunity and the possibility to really look into these features, because for artificial intelligence you need a lot of computing power, and with this development we have a chance to really integrate this into our equipment, because between detection and ejection we have very little time to make a decision to really decide is the particle a product or a waste. So we need to be very quick and very fast to come to this decision. So computing power is really key here. So let's look into definitions, and that's does not really come from myself. It is how it is in the market. So artificial intelligence, that's a kind of buzzword at the moment, because that's not new. That's really something which just, if a machine actually mimics a human thought and can make their decision and perform some tasks, it's a kind of if-else situation, and that's what is quite long in the market. And we in Tomra use this already since the beginning of sorting equipment. So it is already from the beginning a kind of automated system. So also artificial intelligence was used in that time. Then it comes to machine learning. This is an application of AI. So it's just a part of it, which is more intelligent, but already automatically recognizes some patterns, learns from data, and improves certain things without being programmed. That's also what we use for more than 10 years. And we typically use this to set up our equipment properly, to not be so dependent on the people as such. Because you can imagine, if you have thousands of equipments running in field and you have a lot of people, very good service people, but of course, everybody makes things a little bit different. So, and to be a little bit independent from that, we have certain service tools to set up equipment in the most efficient way. And that's where machine learning is used already since years. And now the new thing for us, at least, is deep learning. So that's application of machine learning. And this uses artificial neural networks, which sounds very sufficient to analyze data and to really solve complex problems. And that's what we use now and introduce now with the feature Obtain. And I will tell you what the motivation was to use it and what we actually do. So let's look, why are we doing this? As you have seen, sensor-based sorting, especially on the belt-based sorting, depends really on good particle singulations. So we want to analyze every single rock separately. And if you the singulation of the conveyor belt really depends on different things like mechanical setup, the throughput, so how much material you run through a sorter, the application, and the more tonnage you run, the more throughput you run, the more particles touching each other. So you can see on the bottom right that touching particles with a normal image processing are seen as clusters, and we analyze them as one particle in total. And although there might be some of them product and some of them waste, we really just have one particle which we analyze and we eject the whole thing. And this is, of course, reducing the efficiency, and that's what we want to solve. So being independent of these clusters, cut the particles into single particles again, analyze them again, and eject them precisely. So that's the key, why we looked into that, and we wanted to be independent on the throughput. So have always the same sorting efficiency, without really be dependent on these clusters. So that was the target, being independent of these physical material singulation. And that's what we wanted to achieve. So increase the tonnage with the same and maybe even better sorting results, and improve the sorting efficiency by just increase the detection precision. So really get the clusters separated again in single rocks, analyze them separately, and eject them precisely. So how have we done this? And we really use deep learning approach here, and that means we use artificial neural networks. And I always think about that like a brain, and you need to train this brain. Like on your kids, if they need to learn something, you need to get a lot of data into them, and they can then just combine certain things and make their own decisions. And that's what we also did. So we have our network. We have taken a lot of data from our sorters. So took a lot of images from scanned X-ray particles, materials, feed that and mark that and said, okay, this is a rock and this is a rock and this is a rock. Feed that into the network so that the network starts learning what is a rock. And that's actually just the output of this artificial intelligence network. So we can now just cut these clusters, classify every single particle independently. And that's the key here. So how does it look in practice? So we go through this image step by step. We have on the left-hand side a real X-ray image from a sorter. And if we zoom in, we actually see with our eyes that this belongs to at least 5 rocks. If we switch or the original system without Obtain, without artificial intelligence, see it not as single 5 rocks, it really clusters already this image into 2 specific rocks. And if we then classify this image, the blue color here is high dense material, the red is low dense. And if our decision is that every single rock which has a little bit of high dense material, like we see in metals very often, we would in this case eject all of these rocks at the same time because they're touching each other. So they are classified together as product, and we would eject that in this case. Now with switching on Obtain, we have the chance just with the segmentation to really see these 5 separated rocks. And by classifying it, we are much more precise in the classification, and we would only eject the parts with the blue color here, this high dense material. So we are more precise in the detection and just more precise in the ejection. That's the key of this feature. So that's the real changing, and it's a kind of changing the world because now you can run higher throughputs through sorters. You can still see every single rock, although they might touch each other as the single rock, and then you have a much more precise classification on that. So what is the relevance for the sorting performance? And we are always get the question, is that relevant for every single application? And to be honest, I would say not. It's not. It's beneficial for most of the application, but there are some and very, very few very easy sort. We call it sometimes lollipop sort because it's just a kind of black and white sort. So we have a perfect liberation, you have a perfect waste rock and a perfect product rock. Here just few examples, like in the diamond world. The diamonds are just carbon, perfectly low dense material, and the waste is just high dense. So it's very easy to use simple filter mechanisms to just see the product, in this case as a diamond, as a product. You don't need a kind of particle separation because you don't look at every single particle, you just look at filtered red color. But Also for this lollipop application, the feature Obtain could make a difference if it comes to statistics. So if you really want to get statistics out of the sorting equipment, as it's almost the whole material is sorted through, then Obtain can still make a difference, but not really for the sorting performance in this case. But there are not so many lollipop sorts out in the world. So there are a lot of applications where you have still a mixture of metal and the specific metal within a rock, and you want to see it. And therefore, it's quite important to see single rock to make a decision if that's a product or a waste. And there are different scenarios where the customer need to understand their material, needs to understand what we should eject. Is that the waste or the product? And that's really depending on the mass typically. So if you have more mass on waste on your material feed, then you typically eject the product and the other way around. But it could also differ depending on what you want to achieve. And in this second stage, you need to understand what is your focus. Is that the purity of your material, or is that having the highest recovery? Of course, customers want 100% from both, but that's almost impossible. So you need to decide what you focus on. And there are different applications where it comes like gold ore, for instance, where recovery is key. So you don't want to lose any. And there are other applications where purity is key. So you want to have a highest grade product which you can sell for a better price. So that really depends on the customer and the application and what the focus of the customer is. And just to give you two examples here, I choose ejecting waste. In this case, it is focused on product purity. Here it is industrial minerals. It is a magnesite application. At magnesite and XRT is very pure, so you want to have a high grade product produced. So you want to eject all the impurities. And the challenge here is without Obtain and if particles touching each other, if one of the high grade magnesite particle now touches the waste particles, so some impurities, then it would be misclassified as waste. So you will lose product. It's still a high purity, but you have not the highest recovery. And that's with this Obtain where you have the chance to really separate touching particles and analyze them separately. You create a more output of the system, so more product at the same quality. You will lose less product just as a result in the waste, and by more precisely ejecting the waste, you will also lower the air consumption, which is quite important for customers. So if you look, what does that mean? In this case, as we focus on purity, the purity is very high and very stable in both cases. So with AI feature, without AI feature, but the difference is the product output. So the recovery of the product, the mass the customer can create on good material he can sell is a big gap between the with and without. So you see here already with 25 tons per hour and on smaller grain sizes, you have a gap between without and with Obtain. And by increasing the throughput, if you go to the right, the gap will getting bigger and bigger because higher throughput, as mentioned, means more particles are touching each other. So your precision of sorting goes further down. And that's where Obtain really makes a big difference. And there's a second example, and here the focus is on product recovery. Here I choose tungsten, but it's the same for gold and for other, especially metal applications where you don't want to lose any. And tungsten is seen as little inclusions in the rock. So we have little spots on the image, where the tungsten is sitting, and we want to eject just pure waste, so material particles where we don't see any inclusions. And here the challenge is, if a tungsten particle is touching a, a waste particle, then it will be misclassified and seen as product. And this is it will reduce the product quality at the end. So you will not lose any product, but you will have more waste into the product. So just by switching again on Obtain, so our AI feature, you will create a cleaner product, so you will have less waste in the product. But now with a more precise ejection, due to increase more of the waste, we have a higher air consumption. So that's just to follow the rule, having a cleaner product, we will eject more waste more precisely, so we have higher air consumption. And the picture looks quite similar. So we focus on recovery, means the recovery is very high on both cases, but the removal of waste or the product purity, you can also say, is dependent on a good singulation of the material. So every particle with touch each other has an influence on the sorting efficiency. And this is how Obtain actually works in regards to sorting performance. But as we now see every single rock, and that's one of the big advantage of sensor-based sorting, it's almost the only equipment within a mining processing which really looks at every single rock separately. This has a lot of advantages on statistics. So what we do, we offer a kind of cloud-based platform to our customers, where we collect a lot of information on what the sorter is actually creating. So from every single rock, properties, parameters, and here Obtain, of course, will have a lot of advantages on the precision of the statistics. And this, I just mentioned a few here, is in regards to particle size distribution. So that's much more precise now with Obtain. It's not the big clusters which just have an influence on the data. It's the mean particle size, material composition. As the sorting is more precise, also the data are more precise. And this is a real big, has a real big impact on information. And data in mining gets more and more relevant. So we get more and more requests regarding this. And it's a collection of information which helps to see what's going on in the plant. So what is on the upstream processing steps happening on screens, on other stuff. If size distribution changes, you can easily directly act on it and see, okay, there is something with my screen mats not working properly. And the same on the downstream. So that looking into information which are getting more and more precise and available to customers has a big impact on how they run the plant. So how to react immediately on certain things. So just the summary on the benefits on Obtain, so on this specific artificial intelligence feature. As mentioned, we now have a stable performance independent on the throughput. This was really the key, what we wanted to achieve. And we can almost double the capacity. Of course, this is dependent on application. So we always ask for running test work. So we have test centers around the world, in Germany, of course, where we are located, where our main hub is for mining, but also in Australia, in South Africa and other regions where customer can bring material. We have certain test phases. We do a first feasibility test. So if the material is liberated and our sensor portfolio can really distinguish between the different fractions. After that, we have kind of performance tests, so where we really run tests like in real life that we can see. We run the throughput the customer expect at the end and see what is the efficiency of and the quality of the product and the waste. We increase the sorting efficiency with this feature, so either higher recovery or higher purity. And as mentioned, it has a big influence on data precision. So now it's video time again to make it a bit more live. This is actually a test we run in our test facility, and we use artificial material just to make it visible, because typically in the mining everything is gray, so you cannot really see with your eyes and distinguish easily between product and waste. And just to make it a little bit more visualized, we run specific tests with and without, and you really see the difference. Let's look at it. This is in our test center in Wedel, actually. This is how the picture looks like, analyzed, and you see the big windows we eject. Recovery looks good, but the purity of the product is quite low. So, and here you see the real difference. So recovery is the same, but the product quality is jumped. And that's the feature what changes now the sorting performance, at least of our equipment, quite heavily. So we can look at the customer field evaluation. So what we did, of course, we developed this feature. We tested a lot in the test center here. And after that, we went to a customer and evaluated the same feature in field, just to also gain some field experience in real life, and also gain some data on the benefit and the performance. So we have chosen a magnesite customer here. It's a customer located in Turkey. This customer had already a tertiary XRT running since 2020. And in 2022, we developed a new ejection module with ejectors which are much faster and developed for fine, or at least finer material. Fine for us in sorting, it's 10 to 30 millimeter here. The ejection system is worth from 4 to roughly 35, 40 millimeter. So we had already a good step for the customer with the upgrade of this ejection module, and the customer was already very happy with this upgrade. So he saved around 70% of compressed air. And you need to know compressed air is a quite big operational costs for our customers using sensor-based sorting. So 70% reduction is real money. And this customer we choose for field evaluation for Obtain in 2023. So We updated the system again and run about 10 to 35 millimeter material, and the ejection rate was very high, so it was perfectly for our feature. So that's what we have done together with the customer. And we created a lot of numbers. So we went there, so our application engineers went to the customer, run specific tests, collected information, analyzed the material just to have some numbers to prove the concept. And what you see here on the bottom side on the right, the first image is without Obtain, and you don't really need to see all the different details. But what you see is the white brackets. This is the ejection window. So just it's in both cases the same application, the same throughput, so the same amount of material, but you directly see that the ejection windows are much bigger on the left hand side and on the right hand side. And that's the precision I talk about. So you see on the left hand side without Obtain that touching particles are misclassified and therefore also misejected. And that's the big difference here. With Obtain, you are precise, you can eject precisely, and there is a big change in just the product recovery. So the customer creates more product what he can sell, and this is already 8 to 11%, and then the customer can calculate what would that mean in money and revenue, and that was quite a lot of money he could earn just by having this new feature, without really increasing the throughput. So running the same throughput, you already increased the mass pull to product. We tried to make some money out of it just to make it visible. So we've got some prices for magnesite at that time, at least, and we have seen that there is quite some added value to the customer. Just with he was not running 24/7, so it was about 55,000 tons per year, whereas 35,000 tons is product. So he could earn much more money with this feature. Already with just having the same throughput, he could earn 415,000 euro. And if he in addition increases the throughput, which the sorter can handle, 40 or 50 tons per hour, he even would earn much more money. So, and that's what I wanted to present today. Are there any questions from the audience? Any questions?
So Ines, the Tomra sorting works so well that it ejected me out of the call. So I had to rejoin. There was a question in the chat. If you don't mind, I lost the original chat. So can you repeat the question?
How hard is it to implement the AI system into existing sorting units? Is there an upgrade process? That's a good question, actually. So yes, we have. So it depends a little bit on the age of the sorter, but if it's not 10 to 15 years old, we offer some upgrades to that. So there we quite often try to get equipments installed in field on the latest stage. It's not always possible because there are some really old ones still running, but there is an upgrade package already available, and we also upgraded already systems in field. And we also offered a kind of test time so that the customer can test this feature and see and calculate and make their own calculation on the benefits. And so far, all the customers we offered a trial actually decided to buy it because it is, of course, not just for free, but it's doable in most of the cases. Currently for XRT systems only.
Okay, thank you. Are there other questions? If not, I have quite few, but having in mind that Ines is almost close to 11 o'clock p.m., we want to keep her much longer. If you don't mind, Ines, to talk a little bit about impact on the tailings, because for mining industry, that's really one of the greatest areas of concern. So how is the your technology improving? I mean, you already hinted how it is improving, but if you can expand on the impact on tailings.
Yeah, what sensor-based sorting is doing in general is, of course, processing material before it runs through a real final processing step. So we remove a lot of waste in advance, which does not need to be processed further, not milled, not running through flotation or other processing steps. So everything which you can remove on an early stage are not really into the tailing ponds afterwards. So you can easily also use that material because it's not, yeah, it's pure waste material. Does not have any acid related material in there. So you can use and sell it for aggregates or others. And just by doing this, and in some cases, as mentioned before, we remove more than 50% of the material very early in the process. So it does not need to be crushed, not need to be milled, not need to be further processed. And that's what you reduce your tailings for.
Yeah. Do you know the application where you actually can use this on reprocessing of tailings, let's say dry tailings?
We have, not sure if it's tailings, but material which is dumped and not processed in the past. That's what we also sometimes reprocess currently. And in some application you find more valuable material in dams than what you currently get out of the ground. So especially if we see that the material goes down. So that's what we do.
Yeah, excellent. Being an automation engineer by training myself, the analytics that you're doing on the particle size is just amazing, because all of a sudden you can start using feed-forward control loops and have proactive kind of control of the downstream process, which was not possible before. So that's really great benefit. If there are no other questions, I would like to thank Ines for sharing so much. This is actually very exciting material. I'm hoping this piece of equipment is going to end up on the PFDs and PNIDs going forward. So for all process engineers, metallurgists, they should take a look at this. Thank you, Ines. We'll stay in
Thank you for having
touch.
me.
It was really a pleasure. And thank you all for joining us. Keep an eye for our next installment of this series. We'll keep on learning what AI can do for mining. Thank you all. Good night,
Thank you,
Ines.
and have a nice rest of your day.
Thanks. Have a good night.
Thanks. Bye.
Bye.